Hello, this is Math with Beth, and we are going to learn how to find the antiderivative today. Finding the antiderivative is the opposite of finding a derivative. So if you know what the derivative is, it's going backwards and finding what the original equation must have been. So for some of these, you can kind of think through what could possibly work, but obviously there's going to be rules that help us do all different kinds. So in this case, if you thought about it for a long time, you'd probably figure out that x to the second power would work here. Because if I took the derivative of this, I would use the power rule. I'd put the 2 in front and I'd subtract 1, so I'd get here. But the problem is there could be another number here, because if I had like a +3 here, wouldn't the derivative of that be 0? So you never really know when you're going backwards if there had been some other number here or not. So we're just going to call that C. And unless we have more information, we're just always going to put that plus C at the end when we're doing an antiderivative. And then for notation, instead of doing this type of notation, they are sometimes going to just say, all right, what if the derivative was 2x? Can you go backwards and find the original? And they'll use this notation to show that. So if 2x is our f of x, and they ask for the capital F of x, that's how you know they want you to go backwards and find the original. So again, it would be x squared plus c. But now let's learn some rules so that we don't have to keep kind of going through and guessing what could work. So the constant rule is what we just basically did without knowing. No, sorry, the power rule is what we just did without knowing. But the constant rule is saying if you're doing and this is the symbol for antiderivative, if you want to do the antiderivative of just a number by itself, it's going to turn into that number times x. And then again, we'll add the c at the end. The power rule is what we just kind of did on accident. And it says if you're trying to do the derivative of x to a power, as long as that power is not -1, because that's going to be a special rule that we'll see in a minute, you're going to take the power and add 1 to it here, but then also divide by that same number. So we'll see an example in a minute, but then again, we add the plus c. For natural logs, if you're doing the antiderivative of 1 over x, which is the same thing as x to the -1 power, it turns into ln of the absolute value of that plus c. And then finally, an exponential. If you're trying to do the antiderivative of e to a power, it's going to, again, still be e to that same power, but the extra step is 1 over the derivative of that power, plus c. So let's try a few to see if this makes a little more sense when you see it done. So this would be the power rule, right? So I'm looking at rule 2 to find the derivative, and it would be x to the 7 plus 1, but then I also have to have 1 over that same number out front, and then my plus c. So that would be the original equation. And at first, if you're kind of iffy on these, take your new answer and see what would happen if you did the derivative. Wouldn't we multiply the 8 out front, which would wipe out the 1 over 8, and then we would subtract 1, which would get us to that x to the 7th power. This dx will just always be there to show that they already did the derivative, so it will just always go away when you find the antiderivative. Okay, for b, this would be the power rule also if I rewrite it as x to the 1/2. So don't forget you can do that. So now, again, I'm using this new power rule, which tells me to add 1 to the power, but then do 1 over that power. So instead of writing 1 over 3/2, because that would be a little cluttery, I'm going to instead do this. The same thing as 1 over 3/2 is just flipping that and saying 2/3. Don't forget your plus c. This one's the same in the fact that I could rewrite it first, and then again, just do this power rule. So add 1 to -3, which gives us -2, and divide by that out front. Okay, finally we have a different one. So this is an exponential, so I'm looking at this fourth rule. So the antiderivative is the same thing plus c, but out front 1 over the derivative of this, which would be 4. So that's the extra step with an exponential. For e, if you have a constant being multiplied, you can always just take that out if you want to and not worry about it for now. So that 4 will still be there at the end, but what is the antiderivative of this? Well, that was our rule 3, where it's going to be the ln. So the 4 is still there. The antiderivative of this is ln, the absolute value of x, and then plus c. So those are the basic rules. The only one we haven't done yet is the constant. So just to show you one of those, if we're trying to go backwards with just a constant like 3, the antiderivative would be 3 times x, and then plus c. Okay, let's just do some that are a little more complicated. So first, if you have a bunch of things being added or subtracted, you can, just like when we did the derivatives, we can do them one at a time as long as they're separate like this. So looking at each one separately, this is going to be the power rule, and the constant rule. So for this first term, I'm adding 1 and dividing by that. So I'll be able to reduce this. I'm adding 1 to the power and dividing by that same number. And then for the 8, since it was a constant, it will just turn into 8x. And then, of course, we have our plus c. So the only other thing I could do is see if anything could be reduced. So there is my final answer. 2 is similar, but since it's all being divided by x, I would need a whole new rule for this unless I reduce first. So remember, if you have multiple things on the top of the fraction and only 1 in the bottom, you can split this up by writing each thing on top separately with that thing on the bottom. So I have not done any antiderivatives yet. I'm just rewriting the problem. So we just did one like this where the 4 would come out and the 1 over x would turn into ln, absolute value of x. This next one can be reduced to just 3. So since that's a constant, that would turn into 3x. And this last one could be reduced to 2x to the third. So I'm using my power rule, adding 1 to the exponent and dividing by that number. Don't forget the big old plus c at the end. So the only thing I could do to make this one nicer would be reducing that to 4ths. Final answer. Okay, so that's the basic idea of antiderivatives. But now, of course, there's going to be problems where they give us some more information, and that allows us to figure out what that c at the end is. So if they tell you some other information like a point or its initial conditions, like this problem starts out at a certain place, which is the same as giving you a point, because that would be 0, comma, whatever, then you should be able to find the c. So find the antiderivative of this given that f of 1 equals -2. So again, they're giving you a capital F here, so that's not something I could plug in right now. It's something I can plug in after I do the antiderivative. So power rule, I'm going to add 1 to the power, but also divide by that same power. 3 turns into 3x, and we have our plus c. So we would be done normally, except we have more information. So I can plug in -2 for the y and 1 for the x. And again, I could reduce this. The 2 over 2 turns into 1. So I really just have x squared plus 3x plus c. So I'm going to plug in 1 for the x's. What do I end up with? 1 plus 3 is 4. So right now I have 4 plus c equaling -2. And I can subtract the 4 and get -6. So now I have my final equation, including what the c is. So x squared plus 3x minus 6 is the exact equation. I don't have to have a plus c that shows there might be a constant, because now I know exactly what it is. So in this case, they were just specifically asking me to do that. In the next problem, it's going to be a word problem where we're going to be able to do that. So a ball is thrown upwards with an initial velocity of 50 feet per second from 10 feet above the ground. Has the velocity of this. So here's my velocity equation, where t is the number of seconds after the ball is released. Determine a distance function, h, in terms of t. So here's where we need to remember something we've seen before. In the past, we would have a distance function, and if we wanted anything to do with velocity, we would do the derivative. And then if we wanted to know anything about acceleration, we would do the second derivative. So basically, if they're giving us the velocity equation, they're giving us the first derivative. If they want the distance equation, they want us to go backwards and find the original. So they just happen to say find h in terms of t. So that just means we're going to call it h of t. But basically, we're just going to do the antiderivative to find this equation. So -32t. I'm going to add 1 to the exponent and divide by that number. Plus 50 will turn into 50t. And then there's that plus c part. So I can reduce this a tiny bit. But the key to this problem is that they did give us another piece of information. The initial velocity of 50 was used in making the equation. So this isn't really extra information. But the fact that we started at 10 feet above the ground means that is like our y-intercept. We started here and we threw a ball that went up and then down. So we know our y-intercept is 0, 10. So that's our initial value that we can plug in now. So I'm going to plug 10 in for the y and 0 in for the x. So this could be reduced to -16. So basically, that means 10 is the C. So now I can answer their question with the entire equation without this plus C at the end that I don't know what it is. So that is what you can always do if you have one more piece of information, usually a point. That's your basic information for finding antiderivatives. Let me know if you have any questions, and I'll be making more videos to show what else you can do with the antiderivatives.